Okay, so let's go ahead and get started. The first thing that I want to talk about is version control systems. So if we kind of take things back to basics, if you wanted to work on a application with somebody else, you need a place to store the files that are relevant to your application. So if you were working in C, this would be where your .c files are, and similar with other languages. You could store these on some sort of network accessible location, so FTP or file share. And this will give you a centralized place for everyone to access the files. Unfortunately, though, this kind of gets a little bit out of hand over time, where people, if two people want to edit the same file at the same time, one person will get locked out, and they'll create a copy, and you get copies all over the place. And it begins to be hard to try to figure out which copy is the most up-to-date copy of a file. Also, if you want to go back in time to access previous versions of a copy, they're not available, these sorts of things. So version control systems were created to solve these problems in that they create a timeline history of changes to files so that you can see the current working version and go back and access previous versions in case maybe there's a mistake in the current, you want to go backwards, or you just want to reference something in the previous version of a file, that sort of thing. So from a general perspective, there's kind of two types of version control systems, at least in terms of ones that we're interested in at the moment. First one is centralized. So this means that there's a central server which runs a version control software, and people go and they check out the files on that server and work with it. And the other one is distributed. So this means that instead of the project files being located in one central place, they're located on anybody who is actively working on it. So if there's 3 developers who have their own laptops individually, then there will be potentially 3 or more different copies of the repository. And there's some benefits and negatives to both approaches. So for instance, with a centralized repository, it means that it's fairly straightforward on where to go to access files and not have to worry about your own desktop space taken up with local copies and things like that. Whereas on the distributed side, it's great if you want to work offline. You can have the full copy of the repository locally so that you can go and work on the most current version of the repository or go back in time to previous versions. How these versions are handled differs from one repository to another. Many repositories use the concept of diffs. So for those who are familiar with, say, virtual machine snapshots, you have a single file which has the full contents, and then if you change the file, then the second file is just the difference between the two, and then you use some sort of mechanism to take file 1 and merge it with file 2 and display that to the user so that it looks like they have the most common version. Today we're going to be talking about Git and GitHub. And so Git doesn't use deltas. It uses full copies of files, and they call that a snapshot. Now, this term will be confusing for VMware admins because they understand snapshot as being using diffs, and in Git we're not using diffs. So just consider a snapshot a full copy of a file at a point in time, along with some associated metadata, such as some information about the snapshot, who created it, things like that. So hopefully that gives some background on version control systems. And we're going to jump kind of straight into using Git and working. So please let me know in the chat if there's any questions at all regarding any of this. But let's go ahead and take a look. So for instance, I have a folder on my local computer, and I want to use Git as a version control. So I've already set up this as a repository, which I'll go into a little bit later on. But just to kind of show you an action, so I'll go ahead and create a file. Okay, so I've got a file, and it says hello as the contents of the file. So if I do a git add git commit. So don't worry about these commands just at the moment. Okay, so I've committed this change to the repository. So now if I go and edit this file, so if I echo okay, so I've committed my second change. Now, if I want to go back and take a look at the previous contents of the file, so I can take a look at the log. So log shows us the previous commits. The most recent commit is here at the top, and you'll see my first one, as you can see by the comment that I added is here. So if I want to look at the first commit, you can see I've pulled back that original version. So the version control system, such as Git and others, can be used to kind of work with different versions and copies of files without having to worry about an unmanaged mess all over the file system of people manually copying files and moving them around and all that sort of stuff. So let's kind of move on a little bit. And I think the first thing that I'll do is I'll start working from a Git repository from scratch. So we'll get out of here. Alright, so the very first thing you want to do if you want to create a Git repository is to use the git init command. So the git init command is going to prepare this folder with a set of metadata on how the system is to be used and what's currently in the repository. So if I look here, I don't see anything, but actually if I look at hidden files, I see that there is a .git file. So if we go into that, sorry, not file, but a folder, if we go into .git, we see that there's a number of folders and files. So probably at some point in time, you may be interested to go in and find out more information about these different folders and files, but I'll just cover the major ones here. So the first one, config, is just some detail that you can specify about this repository and how its behavior acts. So if I do cat config, it just has some basic settings here, and I can go in and change these settings and do different things, and I'll use those going forward. The other thing is head. If I do head as a file, and it points to I guess we'll go into it a little bit later, but for right now, you can just consider it the current working copy of the repository. This is actually just a link, so it's referring to refs heads master. So in here you'll see there's refs heads, and so maybe let's cover actually one bit. So if we go up here, I'll come back to that in a moment, but there's an objects folder, and if I go into objects, there isn't much here at the moment because I haven't created any files and committed them. Now, when I do so let's back up. Okay, so I've created my file once again, and I'll now want to create a version of this file. So right now, there's nothing stored in the version control system. So I need to get this version stored in the VCS, and then we can work with it. So there's kind of a few stages that exist within Git for files. So the first one is oops, let me get back to what I'm doing here. Okay, here we go. Sorry about that. So the first one is the working. So this is where you're actively modifying your files and making your changes, creating files, deleting files, all that sort of stuff. The next one is staged, and this is where you tell Git that you're ready to save this modification and prepare it into an update. But it's not going to finalize everything yet. So if we do git add, we can specify the file name. Or if there's many file names that we change, instead of specifying them all individually, we can do -a, which does all. So now this file A is now staged. The next thing we want to do is to confirm that we want to commit Sorry, I just noticed the comments. Yeah, so there's many different version control systems out there. Not everyone has to use Git. There's Subversion, Perforce, all sorts. It just depends on whatever matches your flow. This training, yeah, it's free. It's just me taking my own personal time to just talk about some of the things that I use. And so from my perspective, I'm not a professor or a teacher or anything like that. It's just me talking about the things I use and how I use them, that sort of stuff. So feel free to stick around, Masonic Seal, and yeah, feel free to ask any questions, no problem. Hopefully I can answer them. So once the file is staged, I want it to finalize the update, so I can do git commit. And I'll want to specify a message about the commit, something to give some information. So I can say initial and so now that the file is committed, it's stored into the version control system. So as you saw in the previous little demonstration, I can go and modify these files and do subsequent commits and kind of go back and forth between these different versions as I see fit. But this is the general flow if you're working with Git locally on your desktop. So now, I kind of backtracked a little bit earlier because there wasn't much, I hadn't created a single commit. But now if I go into Git folder and I go to refs, I now have a listing here called master. So in Git, there's the concept of, you can call it a tree. I believe that the technical term is a Merkle tree. But effectively, this timeline of versions is if you picture as a tree. And so when we're starting out, we have the trunk of the tree, and you can call this master. So we just have just the trunk that we're working with. And right now, as you saw when we looked at head earlier, head pointed to master, meaning that what we're working on is the master branch. Particularly the most recent commit of the master branch. In other words, this is also called tip. If I go back and look at objects, I now have files in folders and files in here. So this is where our snapshots are stored. So a commit is a snapshot essentially. And you can't actually look at this file directly. It's just a compression of your snapshot, meaning the file that you have, the changes that are associated with it. Also some metadata such as the commit message and things like that. So effectively, this is where all your files are stored in these objects folders, and Git handles all the, I guess, extracurricular activities about going in and working with these files. So for most intents and purposes, you don't really need to worry about stuff within the .git folder. But as you increase your knowledge about Git, it's probably something that you want to start poking around at and taking a look at and understanding how Git works underneath the hood. So there's a question about having issues between working around older commits and resetting master to an older commit version. Will I cover that? Yeah, that will be covered if there's time. Let me paste the syllabus here into the chat window, so give me one moment. And if I don't get to it, you can just access that link and you'll see it later on within the document. Okay, so like I said, please let me know if there's any questions so far. I've kind of assumed that some people will know what a commit is and things like that, and I've kind of described the concept of a branch only very briefly. So probably the next thing to do is to talk about branching. So if you have an application project, particularly if many people are, or at least more than one person are working on the project, you may have requirements to work on different versions simultaneously. And so for a number of projects, people create the concept of a branch. And a branch is a way to split the timeline of a project, the version timeline of a project, so that there's multiple timelines existing at the same time. So for instance, if I wanted to create a release of the software that has features, I could create a feature branch. And so when I develop on that timeline, that branch, my changes exist there, but I'm not making changes to the original master. So anybody who's working off a master can continue to work so without my changes influencing or changing the files. We can both keep up to date, as in working at the tip of each branch without treading on each other's feet. So you can create a branch for features, you can create a branch for hotfixes, or for any other things. I'd recommend to keep a branch as a short-term thing. So if you create a branch for a hotfix, that you only keep that around enough time for you to develop your hotfix and make sure that you're happy with it. So you can, once you're done with it, merge that branch back into master, back into the trunk. And for future hotfixes, you create a branch for those. If you let a branch hang around for too long, chances are you're going to accumulate a large number of changes that modify files that have been modified by people working in another branch. And when you go to merge that, there's going to be conflicts. Now, conflicts happen all the time, but you have to resolve conflicts by hand generally, and if there's many conflicts and they become quite extensive and a pain in the butt, then people get afraid to merge and it just becomes a major issue. So if you use branches, just create the branch for a short period of time and then eventually merge it back into master as soon as you can. So that's just a piece of advice. Let me talk about some terms. So I kind of mentioned a branch is kind of a split in the commit timeline of a repository. Master is, as I explained before, the default branch that gets created when you create your repo. Tip is the latest commit or latest snapshot in a particular branch. Head is a reference to a commit that you've checked out currently. So whatever commit that you're currently working on, that is your head. If you're working on a commit that's not the tip, as in it's not the most recent commit, it's one previous, this is called a detached head. Another term is merge. So this is when you fold a branch into another branch. So this means that you're basically terminating the branch that you're working on and you're pushing those changes into a target branch. Rebase is a way to change the history of a branch. So if, for instance, let's say you have a series of commits. So you've got commit 1, and then you make another commit, you've got commit 2, and you make another commit, and you've got commit 3. If you branch out from commit 3, so you create another branch, and so you create a commit 4. Unfortunately, in the command line, this doesn't work too well. You can change the history. So actually, let me open up a graphics program. So let me open up PowerPoint, and it'll be easier to explain this. Just bear with me here. Alright, so let me share this out. Bear with me here. Okay, so hopefully you should see PowerPoint on the screen. Let me go ahead and start making some changes here. Okay, so I've got my first commit that I make, and then I create another commit. Whoops. Maybe I should have a better program for doing this sort of stuff. Alright, so here we have a timeline of commits. So we have the very first commit, second commit, third commit, fourth commit. If I branch off and I create a new branch and I create a commit in that, let's call it commit 5, and I can change the so I now have, like, say that file A, and I put in there my name, James, into that. And I can now rebase the history of my commits. And so if I wanted, prior to C4, to change the history of commits, I can use the rebase command to essentially have C5 as the history. So this is probably not a very common tool that you maybe use in a day-to-day work with commit, but I guarantee you'll come up with a need for it every once in a while. But just remember that rebase is a way to change the history of commits. So that is a very long-winded way of explaining, I guess, a simple concept. Maybe I should have prepared these images ahead of time. Apologies for that. All right. So we've talked about some terminologies. So now what we can do is we can do some examples of creating branches. So here, if I look here, I've got my file A, cat file A, it says hello. So now if I want to create a branch, I use the git checkout command, and I do -b, and let's say feature 1. So this is the name of the branch that I want to create. And now I'll make a change. So I'll echo new branch to file A, and I'll shorten some stuff here. So if I use git commit -am and specify new branch. So the A in here is adding files. So before I had two commands. I used git add and then -A, or git add and then the name of the file, and then I use the git commit. I can squash that together and just use git commit -am, and then it will add and commit the file all in one go. All right, and so now if I do git branch, I can list the branches that I have, and the asterisk shows me that I'm working against a particular branch. And if I want to go back and, first of all, we see the contents of file A as new branch. So if I want to go back, so git checkout master. And I cat this, you can see that the file is still hello. So right now I've got two timelines. So one timeline, the contents of file A says hello, and in the second content, or second timeline, the content says new branch. So if I go back to feature, and I can merge these changes back into master. So let's say I'm all done with this particular branch. So I can go git push origin, so that's and master. Whoops. Oh, okay. So I'm not actually working against GitHub at the moment. So let me park that for the moment, and let's talk about GitHub before I go on. Okay, so GitHub is a website that can be used to work with other people. And so there, you could use a Git server or stand up other solutions like Bitbucket and different things like that. But I'm going to cover GitHub today. Obviously, it's quite common to work with, particularly across different orgs, different companies, or different projects, different people, that sort of stuff. So if you haven't already, I'd highly recommend going through and creating a GitHub account. And that way you can kind of follow through some of these steps. So let me bring over a screen. And resize this. Right. Okay. So here you should be able to see my GitHub profile that I've created for this demonstration, and So what we'll do is we have a local repository that we've made, but we now want to store this repository also on GitHub. So we'll walk through some of the steps on how to do this. First thing that we want to do is to create a repository on here. And so create a new repository. And what do I call this? Demo 1. Okay. And there's a couple of different ways you can do this. So you can create the Git repository on GitHub first, and then you can clone that down to your system. Or if you've already created the repository in your system, then you just need to add GitHub as a remote. So helpfully, GitHub creates these commands for you so that you know what you need to do in order to follow the advice. So I already have an existing repository, so I'm just going to go and add that as a remote. So let's get back to master first. And so now if I do a git remote -v, I can see where my remotes are. So remote is, as it basically says, a remote location for a repository. And now, so if I come back here, the next helpful command is to be able to push the changes. So origin is your default remote, and master is the branch that you want to push. So if I go push -u, origin, master, and so for the first time I use this push, I just need to specify the u command to set up origin. And it will now communicate to GitHub and push the current changes. So let me sign in. Okay. So now if we go, actually I just realized that that screen probably, the Safari screen probably just overwrote what I just showed. So let me move this. Sorry. So let's go back again. So the first thing I did is I added the remote. The second thing I did is I displayed the list of remotes just to show what's been saved. The third thing I did is I pushed the contents of the master branch to origin, which is our remote, the GitHub site. GitHub asked me to sign in with my credentials, and then it told me it did what I asked it to do. So if I go back to Safari and I refresh demo 1, I now see that I have a branch master, and I now have a file A, and if I click on that, the content is hello. So now, the next thing I want to do is push the other branch that I created. So let me minimize this, and git push origin, and the name of the branch that I want to push. Okay. Now, if I go back to Safari, and it looks like it's already refreshed, but let me just refresh anyways. I now have different branches here. So I can toggle between the branches by clicking on this, and I can see file A, the content is new branch. So the next thing I want to cover is working against repositories that are controlled by other people. So this means, like, say for instance somebody has a cool application that they're working with, and you want to provide updates. It's unlikely that they're going to grant you rights to edit the repository directly, so you'll have to jump through a couple of hoops in order to provide your updates back to them. So let's give that a try here. So I have this account, James65536, and repository demo1, and I'm going to go on my other account, and I'm going to fork this project. So a fork creates a copy of the repository under my name. So let's do. Unfortunately, you won't be able to see it on your screen when I fork this, but it's actually not too much to it. In fact, I would recommend forking it on your own screen so you can follow along with me. But just bear with me while I do this. Essentially, I'm going on my other account and I'm just navigating to this repository and clicking the fork button at the top. Okay, so I'm just going to wait a few seconds while it does the fork. Okay, and so now the next thing I want to do is I want to clone it to my local laptop. And let's minimize this and go back to the command prompt. So here I have my local laptop, and I want to clone the repository down. So on Git, I use the git clone command, and then I tell it the information, the Git file on which I want to clone. So I've copied that over. And now it's created the folder containing the content. So if I go to cd demo1, and when I cloned, I just cloned master. So if I cat file A, it should just say hello. So now let's say, for instance, I want to create a file, and I want to send that new creation back to the original project. So oops. Okay. And so it's probably generally a good thing to, when you create your changes that you want to submit to a public project, to do it on a branch. So we want to do git checkout -b, and call this James Dev. Okay. So now we can do git commit -am. Oops. And so now this file is just on my local copy of the repository. It's not even on my my GitHub account. So now I need to push those changes. So git push master. Oh, whoops. I need to push my branch. So let's go James Dev _1. So now, when I look on the GitHub page, I should see the branch that I did. So bear with me here. Well, I've got some screen juggling that I need to do. So this may take a couple minutes. If while I do this, if there's any questions at all, please pop it into the chat window. But apologies for the quietness while I do these changes real quick. Just bear with me here. Almost done, just one more minute. Okay. So now I'm on my other account, so James65535, and I have pushed that branch, so JamesDev1, and I can compare and create a pull request. And so essentially what I'm saying is we're going from 65535 to 65536. And here is my first pull request. So I've sent that off to the other account. So if I switch over to my other window and I refresh this, I'll now see that I have a pull request show up. Actually, let me just make sure that I've got the right window shown here. Okay, so you should see now the Safari window, and on here, I've got a tab and it says pull requests. And in here, I see the request that I made from my other account. Within, I can see the comments. So presumably, maybe in the comments, they would place some information about maybe if there was an issue that was originally submitted to request this change, they would reference the issue number here, or put in some other information. Here I can see the commit information. And if I look at the actual commit or the snapshot itself, I can see that they created a file, and It's a new addition. So I can decide if I'm really happy with this submission that I want to merge it back into master. So I've got some issues, some options here. I can squash and merge, rebase and merge, but to keep things simple, I'm just going to create a merge commit. And I've just merged that into master. So if I go back to demo 1, and I can see I'm on the master branch, and now file B has been created. So I think that's what I did. Let's go back to the command window. Let's take a look. Yeah, so file B content should be a new file. And if I go back here, file B, new file. Okay, so that's the general flow for submitting pull requests to public repositories. We don't have rights to edit that repository contents directly. Let's take a look. There's a couple questions. Let me look at those. Okay, so there's a question about if you create a project on GitHub, can you change the name of the project later on, or is the project name permanent? So to answer that question, I haven't changed the name of a project on GitHub. I'm sure that you can. You may have to jump through a few hoops. So if we just take a look now and see what we can do. If you go to the settings page, there is a option for repository name. So in here you can go in and type in a name of repository. If there's already a repository of the same name, then you probably won't be able to create it as that. So that's why there's doing a little bit of a check. But if you go in here and you change the name, you can rename it here. So now you can see the repository name has changed. So hopefully that answers your question. And I think that's kind of where I want it to get to in terms of basic Git functionality and working with GitHub and different things like that. There is, as I mentioned before, like say for instance, you made some changes that you don't want. So let's cover some stuff about that. So yeah, let's go back to our window, our bash prompt. Okay, so we can see that I pulled in that merged file. So now let's say I echo this file. Let's see. Okay, so I've created a commit, and so effectively I created a snapshot of this file, and I've decided actually I don't want to keep this snapshot around. It was a complete mess up. I don't want it anymore, and I don't want to push it to origin. But the thing is now my local repository is different than what's stored on GitHub. So if I do another git pull, it's not going to get rid of this file for me. So what I need to do is I need to get rid of it. So the first thing to do is to use git fetch origin. So this is going to go out and pull down the latest contents the latest commits to the GitHub repository, but it's not going to merge them. The next thing I want to do is use the reset command. So I'm going to use reset hard, and I'm going to tell it to look at the GitHub repository, and I want to use the master branch. So now, if I take a look, I see that I've actually erased the commit. And by erasing that commit, I've essentially erased that file, because in my working directory, all I see is the contents of any particular commit, whether that's tip as in the most recent commit of a branch, or a previous commit that I've checked out at some point in time. So I think that kind of wraps it up for the Git usage. And unfortunately, I've actually ran out of time for today in terms of some other stuff that I wanted to get to. Wanted to talk about sprint planning and things like that. But it looks like we're going to have to save that to another session. So just going to pause now and see if anybody has any questions on some of the content that I covered before I wrap it up. So please post in chat. Let me know if you have any questions, and I'd be happy to go into it. Okay, so I think we're going to just about wrap this up. The one last thing that I did want to talk about is issues. So issues is where people can go and specify things that they want to change about a project. So you can create a new issue and say new feature X, and tell them I want feature X. And you can create an issue, or you can create an issue to say bug in program, it crashes when I run it. So if you find bugs or issues, or for instance, let's say that in the public documentation for a project, you can submit that. So issues can be used for any number of things. And maybe for another time I'll talk about how we can use issues to work on the project to improve it going forward. But that's it for today. Thanks everyone for tuning in. Really appreciate it. And I'll catch you the next time. Thanks.